Chandrayaan 3, the mission that we all are proud of. So let's have a look at what exactly this particular mission is and what exactly were the objectives, and let's have a look at Chandrayaan 3 mission. So the news says that ISRO, of course, has already launched the third lunar mission, which is the Chandrayaan 3, which is launched after the failure of the Chandrayaan 2 mission because it could not land softly on the lunar surface, right, in the South Pole. So this is going to be the first mission to soft land near the lunar South Pole. So India has become the first country to softly land a spacecraft in the lunar's South Pole, right? So that's a great achievement from the ISRO side. Let's have a look at what exactly the Chandrayaan 3 is. So, and what were the various objectives. So basically one of the objective was to demonstrate the end-to-end capability to safe landing and roving on the lunar surface. So we can land properly and we can put out the rover and we can roam about in the lunar surface. That was the most important objective. To check that particular technology and capability of the ISRO was one of the most important objective of this particular mission. But of course, there were other objectives as well. So first of all, let's have a look at the components of the Chandrayaan 3. So basically, it consisted of three components. One was the lander module, something which will land. The other was the propulsion module, which will take the lander and the rover from the Earth to the lunar surface, the propulsion module, right? And third was the rover, of course, which was there within the lander and which came out of the lander once it landed on the lunar surface, right? So the mission life was exactly 14 Earth days, which is one lunar a day, and the launch vehicle which was used was LMV-3 from the Sriharikota place, right? So India has become the fourth country along with these countries, which is US, China and the Russia, to successfully perform a controlled landing on the moon, but the first country to do so in the South Pole. Yeah. So let's have a look at the various components of the, just get ourselves aware about the various components of the Chandrayaan 3 mission. So first of all, let's have a look at the integrated model, right? So this is the propulsion module. It has various engines and the propulsion module. And then here we have the lander, right? Here we have the lander, that is the propulsion module. Okay, so we need not remember what exactly are the engines and everything, each and every components of it, but it's very important to understand and be aware of whatever was there, right? Let's have a look at the propulsion module in more closer view. So this is the propulsion module. Here we can see the engines over here, right? And we can see the system wherein the lander will be set up, right? And it also has various payloads, which we'll discuss later in the slides, right? So let's have a look at more closely at the lander. These are the lander, the various payloads, the chastity payload, then the lander horizontal velocity camera to measure the velocity, the reaction wheels are there, various kind of Ramba payload is there. We'll have a look at what exactly these payloads are all about. So this is how the system looks like. Let's have a look at the rover. Very interesting, it has a solar panel, then it has various wheels which are there, then it has solar panel hinge over there, and antennas are there, right? Electronic box is there. So all these things, wheel driving assembly, so all these things are there in the rover. That is how the rover would look like in the Chandrayaan 3, right? Now this is very interesting because here it shows how exactly Chandrayaan 3 went from Earth to the moon, right? So this is the integrated module phase. So what exactly happened was the LMV-3, with the help of LMV-3, the space rocket that we saw earlier, it was launched, and then it would rotate around Earth and it will keep on increasing the orbit. Okay, as you can see over here, the orbit is keep on increasing and it is gradually moving towards the lunar orbit, right? So this is known as the lunar transfer trajectory. Now this is so it is going like this, and then again it is improving, then again it is going like this, and then it is entering into the lunar object. Then in the lunar, again it will be very far, so it will gradually reduce the orbit. So here the orbit is reducing, right? And till this point here just have a look at it over here. So at this particular point, the lander is going to get separated from the propulsion module. Okay, so now only the lander will land on the moon surface, and the propulsion module will keep on orbiting the moon, in the lunar orbit. Okay, so that is how it happens. At one particular time, the lander will come out of the propulsion module, or will detach from the propulsion module. As you can see, it was attached over it only, and it will land on the lunar surface, which it actually landed very, very safely. Okay, so this is how the entire trajectory happened. Now let's have a look at the objectives of the Chandrayaan 3 mission. So we already saw, technology demonstration, soft landing and everything, but then there were various other payloads which were there. So let's have a look. The mineral content of the moon was to be diagnosed, right? The topography of the moon was to be diagnosed. What exactly is there? How exactly the topography is there? What kind of elevation and everything, right? Then moon's atmosphere was to be diagnosed. What kind of air, what kind of molecules, what kind of elements are there in the moon's atmosphere, right? And how moon is interacting with the sun, the solar flares and everything. All these things were to be detected, right? And since we if we understand more and more about the moon, we will get to know more and more about the earth as well, and about the universe that we live in, right? So understanding about the moon's origin and the evolution, and which is going to be, because moon can act as as a stage to launch future missions. So therefore, we need to know more and more about the moon in this particular mission. So that is there. So various technologies are mentioned over here. For example, the velocity meter, altimeters to measure the altitude, right, height, inertial propulsion system, and various navigation control system. All these things are measured, written over here. You can just have the basic understanding about it. To measure, to understand, and to go for all these objectives, we had various payloads. Okay, so lander had different payload, the rover had a different payload, and the propulsion module had a different payload. Okay, so that's one of the most important payloads, by the way, in the propulsion module. The shape, let's have a look at the shape first of all, right? So it is spectropolarimetry of the habitable planet Earth. Okay, so with this particular kind of a payload, ISRO is trying to catch the vibrations, or kind of spectral, the light emitted from the planets which have life, right? So it already has the light from the earth. Look at this particular picture. So when you're there on moon, the earth has a particular spectrum, right? It emits light in a particular manner. It has some kind of a let's say identification, and this is the identification of a planet which has life. Okay, so now what ISRO is trying to do with this particular payload, the shape payload, is that wherever this planet, wherever any other planet or any other object in the universe is giving such kind of signature, okay, such kind of signature, just like similar to Earth, we can predict, or we can assume, or at least we can move forward in that direction, that that particular planet can have life, right? So that is why this particular payload is very, very important from this particular mission's perspective. Okay, that is number one, which you have to remember. Okay, so there are other payloads also. The Ramba payload, which is measure the near surface plasma. Okay, then we have the Chandra's surface thermo-physical payload, which will measure the thermal properties of the lunar surface, the temperature which is over there, right? Then we have the lunar seismic activity, what kind of seismic activity, geological activities are happening on the moon surface. Then we have the alpha particle X-ray spectrometer, to derive the chemical and the mineralogical composition to further enhance our understanding about the lunar surface. What is the mineral composition of the lunar soil which is over there? And then we have the LIBS payload, which will determine the elemental composition of the moon. So these are the various payloads, and through these payloads we have understood what exactly this mission is all about. Okay, so let's have a look at what exactly the LMV-3 is there. So that is basically the GSLV Mark 3 only, which is a 3-staged rocket. We know that, right? 3-staged rocket. The PSLV are 4-stage and GSLV is 3-stage. So what are the 3 stages in the GSLV? We have a solid state, right? Then we have a liquid state, and then we have a cryogenic state. So what exactly is the cryogenic? The liquid hydrogen and liquid oxygen are being used. What is the benefit of this particular thing? We have already seen about the cryogenic engine when we were discussing about the Dhawan 2 engine in one of the months, right? So cryogenic engine, of course, it has more density, it has more thrust, it is much more efficient when compared to the solid and the liquid. So it gives more amount of thrust with limited amount of fuel, and that's the highest end of technology which which is available right now. So for example, the hydrogen has a boiling point of almost like minus 250 degrees Celsius, something like that, and then the oxygen will have a boiling point of minus 183 degrees Celsius. So to maintain these things in liquid stage is a very, very big challenge, right? And that is the challenge which we face in the cryogenic engine phase. Okay, but then since India has developed its own cryogenic engine, that's a great achievement by ISRO, right? And we all are proud of it. Okay, so that's all we wanted to know about this particular LMV3 over here. Let's have a look, let's have a look at the difference between, since we've all, this is Chandrayaan 3, so we also need to know about the details of Chandrayaan 1, 2, obviously, right? So let's have a look at the difference between Chandrayaan 2 and 3, because Chandrayaan 3 was launched because Chandrayaan 2 basically failed. So let's have a look at the main differences between them. So in Chandrayaan 2 there was an orbiter. Okay, but in Chandrayaan 3 we have a propulsion module. That is number one difference. We had a lander and the rover in both the Chandrayaan 2 and 3. Okay, some kind of extra fuel was also included in Chandrayaan 3. Like since we failed to land properly, the landing legs were made more and more stronger. In Chandrayaan 3 we only used 4 engines, but in Chandrayaan 2 we had 5 engines. That is something which we have to remember, and it can be one of the options in the prelims examination. Then the Chandrayaan 3 had larger solar panels. Okay, that's one of the changes. And the landing site was changed slightly, not very much, but it was obviously in the South Pole only, but the site was changed slightly. Okay, and of course the software, because the problem which was found ultimately why Chandrayaan 2 failed was that the software had less tolerance limit. Okay, so what exactly happened was, let's say we have to come down when we are landing, we have to reduce the velocity gradually, right? So let's say we're coming down from 15 or let's say 55 velocity to 45, then we had to come down to 35, right? So it had these modules have stages. It cannot come back to 40. From 45 it can go to 35 only, right? And let's say the conditions demand that I reach to 40 only, so that is where the module failed. Right, so now in this particular Chandrayaan 3, we had reduced it. So we can come from 55 to 50 also, then from 45 to 40 also, something like that. So we had more stages, and that is why we could control the velocity much more better as compared to the Chandrayaan 2. So those were the changes which were there in the Chandrayaan 3 as compared to Chandrayaan 2. Okay, so let's have a look at the findings which can be important from the prelims perspective and even from the mains perspective. So Chandrayaan 1 mission, it was launched with the help of PSLV. That's again one of the very important differences. Okay, and Chandrayaan 2, the launch vehicle was GSLV Mark 3 only, similar to what was there in the Chandrayaan 3. Okay, the dates we have to remember, 2008 and 2019. That is something which we have to remember. The most important discovery by the Chandrayaan 1 was that there is water on the moon's surface. Alright, that is number one. But this water, the discovery of water on the moon's surface, though we had this particular information almost clearly that there was some, but the confusion was whether that data was coming from the hydroxyl group or it was actually from the water, because even water has this hydroxyl group, the OH group, right? So this was the confusion. But Chandrayaan 3, Chandrayaan 2 finally, found out that yes, that both OH group and the water molecule both are present on the lunar surface. Right, so this was the start of finding water on moon, and this confirmed that exactly yes, water is there on moon. So that is one of the important findings by the Chandrayaan 2 mission. So Chandrayaan 1 was responsible for finding the chemical and the mineralogical mapping of the moon, then the terrain mapping, the topological mapping, right, and the temperature and the radiation measurement. So all these things was also done by the Chandrayaan 2, but minor elements, for example, magnesium, sodium, calcium, titanium, all these things were found out on the moon's surface. Magnetic evolution of the moon was found out, right? How exactly moon is interfering, or how exactly moon is dealing with the solar flares, and from the moon we could study more about the solar flares as well. So that is again one of the achievements of the Chandrayaan 2, right? And permanently shadow regions were studied more and more by both the missions, but more by the Chandrayaan 2 mission. So these are the findings which we can remember from the exam's perspective.